task on our hand, and the task is for us to make use of the data available to conduct an analysis to show if there is an influence of teacher experience on teachers' pedagogical knowledge. Now, we'll be doing this knowing that we have the teacher's pedagogical knowledge as a variable and also teacher experience as a variable. However, we'll be looking at the experience of teachers at 4 different levels. Having this kind of statistical arrangement will mean that we'll be conducting an ANOVA kind of analysis. Below, we have the sets of data that has been provided for this purpose, which I have here. And this data I'm going to impute in SPSS. Okay, I've copied this data and I've formed an Excel file with it. And with that Excel file, I'll insert directly to SPSS. We have over about 100 data here, and so it will take a longer time for us to impute. So I'll simply go straight to SPSS, and from SPSS I go to File. From File I go to Data, and then from Data I find where that document is. I think I have it on my desktop, and then I have to identify the kind of document that it is, which is Excel, and then look for it here. Okay, 802 tax. So that's where I have it, and then I say okay, and so it will insert okay here, and then I'll have it on SPSS directly without having to go through the stress of typing one after the other. So I have it on my data view. On that variable view, you can see I'll need to have a little bit of adjustment here. I do not need serial number, so I'll go back to my data view and take it off since it's not needed. So now I have my dependent and my independent variable. If you remember, the independent variable will be tested, which is teacher experience, will be tested at 4 levels. So I have to clearly identify that under my values here. And then the value, we said 1 is going to be from 0 to 5 years. So I add 2, that is the second group, will be from 6 to 10 years. I will also add that. And then the third group will be from 11 to 15 years. And lastly, we have the fourth group of teachers that fall between 16 years to 20 years of experience. Okay, so sorry, I have so I need to add before I say okay. So I have the classification of the 4 groups here, and then the major is nominal. It actually have an order, so we can say ordinal, but it doesn't make difference there. Here is scale because the variable for the dependent variable, it's continuous. The measurement scale for the independent variable is continuous, so it falls under scale. Now from here, where I go back to my data view, since I've clearly arranged them, and I go to analyze. Under analyze, I go to compare mean, because this is a parametric test and it has to do with comparison of mean to know if there is a significant difference. So we go to one-way ANOVA, and then from here we have dependent variable, dependent list box here, where we put our dependent variable, which is teachers content knowledge, and then we have teachers experience that will be added under the factor, which basically is the independent variable, because that's where you have your groups. Here we have we are going to look at test for some things. We are going to carry out a post hoc test here to know, since we are having differences, we are looking at the differences, we have to be able to identify the differences between the groups, where it is actually coming from, in case we discover a significant difference. Here we will not be able to use Turkey. I think basically because Turkey, we are not dealing with sets, groups of independent variables that are actually the same in terms of the number of members in that group. So Turkey will not be able to use Turkey. And Ben Ferroni, no. So we go with Sheffer, and then we will be testing at the significant level of 0.05. So we say continue, and then we go to options. Here we'll have to check for descriptive, where we'll check the mean values. We'll look at homogeneity, which is one of the assumptions for performance of ANOVA test. Now, if we're not sure of this homogeneity, we'll have checked for Welsh and Brown-Forsyth test. But since we are sure of this, that we have homogeneity, it's certain, so there is no need for these two. So we just go straight to means plot that will give us a graphical representation of the data. Here we say exclude cases, analysis by analysis to give us distinction. And here we just say continue, and then we say okay. Voila, we have our data analyzed here. Okay, so we have to look at the data for us to know what the interpretation is. First, we have the descriptive statistics here, which shows the 4 different levels and their mean, the number of members in each group, and then their mean score, the standard deviation, standard error, and so on and so forth. So from here we can see that the mean score has a progressive increase across the group in terms of teaching experience here. However, we'll move to homogeneity to see if there is if the samples follow the assumptions of homogeneity. And from what we have here, we have the degree of freedom as 3, and then the significance level here, we're having 0.42. So this shows that it is higher than 0.05. So it means there is no significant difference, meaning that it follows the rule of homogeneity. So we are safe. So from the score under ANOVA, we can see the between group difference and within group score as well. So from here, we have the F value of 12.387, and then the significance of 0.000. So this means that this sample, the groups, the independent variable, actually possess what is have significance difference. But however, we cannot get full detail of where the differences are coming from until we look at the post hoc test. So we go down to look at the post hoc test to really identify where the differences are coming from. So from the first box, we have comparison between the 0 to, so like I said, when looking at the Shefe post hoc uh, analysis that we did, we can see that the teacher experience of 0 to 5 years, the group of 0 to 5 years on this side in relation to these other groups where we have 6 to 10 years, you can see that it is significant based on this score that we have here. For 11 to 15 years, we can also see that it is significant as they are all less than 0.05. So they are all significant. So there is a significant difference across between the groups. Then 6 to 10 years and 0 to 5 years, we can also see that there is a significant difference. 11 to 15 years, there is no significant difference because it is greater than 0.05, and the same thing for 11 to 20 years. So within this group here, there is no significant difference when we are looking at teachers' experience of 6 to 10 years with teachers' experience of 11 to 15 years. Basically, there is no significant difference. And then we have 11 to 15 years and 0 to 5 years, which shows significant difference here. But for 6 to 10 years, just as we saw earlier, and here's 11 to 20 years, there is no significant difference. For 16 to 20 years, as expected, 0 to 5 years, there is a significant difference. But for the other two groups, 6 to 10 years and 11 to 15 years, there is no significant difference there. Okay, so it is clear that we have been able to identify where the significant difference actually lies. So from the means plot, where we have our graph, we can see that the mean score for teachers' experience and mean of teachers' content knowledge shows a progressive increase as they move across the 4 levels of teachers' experience, with 16 to 20 years of experience having the highest teachers' content knowledge. And then the list is 0 to 5 years. Here there is a very sharp increase when it comes to 6 to 10 years, but it's a bit steep when you have from 10 to 20 and to 15 years, and then 15 years to 20 years. It's not as sharp as we have at this stage. So we can simply infer that once they get to 10 years of teaching experience, basically the differences in terms of content knowledge may not be as much as when they are at the early stage of their teaching experience. Thank you.